This is Marlene Einhelig reporting from Dillingham, Alaska, which is located about right here. I am working on the Unit 12 screencast, and first I will be going over the TV weather maps with you. Sunday, the 22nd, there's most of Alaska is covered with cloud cover with spots of clear sky. And as you can see, there's a stationary front that goes from the west of the Alaska Peninsula into interior Alaska, and an occluded front that is blowing north from the North Pacific. And there are a mixture of fog, snow, and rain with a low pressure system just south of the occluded front. Monday the 23rd, the low system is down here on the west side of the North Pacific with troughs, and another low with troughs with a mixture of rain and snow. And today, most of Alaska is covered with cloud, with more of Alaska with clear skies than the day before, and a high system that goes from the west of Alaska over to the top coast of Alaska and to the interior. Tuesday, the 24th, there is a persistent low system with a trough that goes into the interior of Alaska with an occluded front that is persistent and is blowing north into Alaska with a cold front and a warm front, and the high system that goes from west of Alaska over to Canada. Today, the skies are mostly clear throughout Alaska, with the cloud cover still on the coast, the northern coast of Alaska. And here's Wednesday's forecast with the persistent low system and the occluded front that moved up onto the southern coast of Alaska, and the trough that is with it, with a mixture of rain and snow and fog that goes from the Alaska Peninsula across the North Pacific. Here's Thursday's forecast with the persistent occluded front, the persistent low system, and there's also still the mix of rain and snow and also fog that goes through the Alaska Peninsula into North Pacific. And here's an cold front with a warm front and a high pressure system just to the west of Alaska, the state of Alaska. And Thursday's actual weather, here's the low system with a trough and the occluded front that's on the southern coast of Alaska with a warm front and a cold front, with, again, Alaska covered with clouds with a mixture of rain and snow. Friday's weather, here's a low system with a trough that goes from the Alaska Peninsula into the interior of Alaska with some cloud cover throughout Alaska with patches of clear sky. And here's the occluded front and the persistent low pressure system. Here's Saturday's forecast with the low system, the troughs, and the occluded front blowing into Alaska from the North Pacific with a mixture of rain and snow. And lastly but not leastly, here's Sunday's weather with the persistent low pressure and cloud cover throughout the state of Alaska with patches of clear sky and a mixture of rain and snow throughout the Alaska Peninsula into the southern part of Alaska. And over here is the occluded front that has seemed to move to the west side of the Alaska Peninsula. And now on to the screencast questions. What method of forecast was most accurate? I came to find that the persistency method was most helpful, especially in the short run, and proved to be true with the persistent low pressure in the Alaska Peninsula and the North Pacific throughout the week. The second question, did the NWS forecast show skill? I chose yes, and I found that the NWS forecast assessment showed remarkable skill in the locations of Dillingham, Kenai, somewhat of Fairbanks, and Northway, and Dead Horse, according to the table 4C of our worksheet. On to the next question. In what region were the forecasts most accurate? Using the persistency forecast, I found that the Bristol Bay regions showed to be most accurate, and using the climatology forecast, Dead Horse showed to be the most accurate. And using the NWS forecast, the regions of Bristol Bay and the Arctic proved to be the most accurate. So I found that, each system showed to be more accurate in some regions than others, and they all resulted in some regions with all A's and others that showed B's and F's. And we were asked, can you give any reasons for why forecasts might be more accurate in some geographic regions than others? Well, I've learned that the local weather is greatly influenced by geography, and also I learned that fronts are responsible for most changes in the weather, and also that they can make it difficult or result in a wrong forecast. And knowing this, every weather forecast is just a prediction and is based on the chance that the weather will change or that the weather will act together. The next question, can you give any reason for why forecasts may be more accurate when high pressure rather than low pressure is present? Low pressure systems can bring stormy weather, and the first thought that came to my mind was winter precipitation, since of course we're studying the weathers and climates of Alaska. I've learned that winter precipitation forecasting can be difficult, and no matter the location, and every place has its own specific set of complications when it comes to winter precipitation. So that would be my best answer. Our next question deals with southwestern region of Alaska, and it asks us to discuss how the passage of cyclones through the region influenced the temperature observations at these stations of Bethel, Dillingham, and Kenai. As you can see, the persistent low pressure throughout the week in the Alaska Peninsula and the North Pacific. These low pressure systems brought a rise in temperature and also brought cloud cover, as you can see, which helped the heat in the southwest region area stay warmer through radiant heat, and this would be especially true at night. The next part of the question asks us to discuss how the weather at Kenai might have been different on Sunday, March 29th, if the low pressure system, the cyclone, had followed your student trend forecast. Well, my answer would be if the student forecast would have been correct and it had moved to the east into the peninsula, into the Alaska Peninsula, the weather could have possibly been less cloudy and dry over Kenai, which is somewhat over here where my mouse is. But then of course, the low pressure system moved over into Kodiak, which caused a different outcome. On to the next question asks, discuss how the cloudiness and wind conditions contribute to high temperatures across the state. Throughout this assignment, I learned that warmth from the North Pacific, the persistent low pressure system that was present in the Alaska Peninsula and the North Pacific throughout the week had contributed to the higher temperatures across the state. Also, the cloud cover at night could have also contributed to the high temperatures, because when clouds are present, some of the heat that is emitted from the Earth's surface that is trying to be released into the sky surface would be trapped by the clouds and in turn be re-emitted back down towards the surface. This would cause the temperatures to decrease more slowly than if the skies were clear. And throughout the week, as you were able to tell, there was a lot of cloud cover. And also the wind throughout Alaska blew out the cold temperatures and blew the warmer air from the south where the occluded front was. Excuse me, that was actually the weather maps for 324 and 321 for 326. I don't know if it was just me, but I didn't see a map for 321, but I do have one for 324 for 326. And by looking at this map, here's a low pressure system with the warm occluded front blowing into Alaska. With this, the temperatures would be warmer with the front here blowing into Alaska. And it says the forecast from 321, and I learned from this chapter that the further out the forecast is, the most likely it may not be correct. So since the 24th is within the 3-day forecast from the 26th, 324 would be the choice that I would choose to have been the most accurate. And that's it. Thank you.